those notes are mine, so I don't know if that even really matters. So today, we're discussing parallel lines and transversals, but to talk about that, we would probably need to know what a transversal is. We should know what parallel lines are. Parallel lines are... yeah, lines that never touch, right? Lines that never touch. They run at exactly the same angle to each other. So a transversal is this line right here. So if you have a highlighter to play along as we go, you could highlight T, highlight the word transversal. A transversal is a line that crosses another line. So it is really like a crossing line. And it creates an angle. Well, you can hear what I said, though. Creates angles. So this transversal T creates some angles. And because I'm such a nice guy, I went ahead and numbered these angles for you. There are 8 of them. Ooh, look at the angles. Now we have some more vocab words that, again, because I'm such a nice guy, I went ahead and wrote down for you. All we need to do is notate what angle is corresponding to another angle, what angle is alternate interior with another angle. So let's go through these things. First off, we have interior and exterior referring to the parallel lines. So first off, wait a minute, do we know that lines A and B are parallel here? We don't. If lines A and B are parallel, they should actually indicate that they are parallel with arrows facing the same direction. So go ahead and add, I don't care where on the lines, arrows, not the end arrows. That just means that these continue on. You have to have arrows on the line, and a lot of times they'll do a double set. Nah, just a lot of times they do. Corresponding means they're in the same place. So if you want, you could go ahead and write down this definition means same place. But what I mean by that is angle 1 is on top and to the left, right? Compared to the parallel line, angle 1, hey, you need a set of notes. I know it's crazy, but now that we're back at school, I actually have notes to give you guys. I know we've been back for a little while, but I finally have my feet under me. We actually might, Douglas, need you to go to another classroom. Or you can just, yeah. Douglas, let's go find you a better place. Or why? Actually, here. We'll do this. Because people are coming and going and getting weird. There's space for that. Watch your bags. Yeah. Actually, we'll do this. Whoa! Ollie. Ollie. There you go. Pop, shove it. All right, so what do I mean by same place? Angle 1 and corresponding are also congruent to each other. So this symbol means congruent. It's an equal sign with the little squiggly on top of it. So we don't always have to use that, but that's what that means. Angle 1 is on top and to the left. Down here, what angle's on top and to the left? 5. And these are angle symbols, right? Another example of corresponding. Angle 2, and what other angle? On top and to the right? Yeah, on top and to the right. Oh, shoot, the other thing I forgot to write down. If A and B are parallel, you could also write A, that symbol B. That means A is parallel to B. That symbol means A is parallel to B. Alternate, what does it mean to be alternate? Different, right? So alternate interior. Okay, so if we had angle 3 is on the inside, not same side, 6. So actually, angle 6 is the alternate interior because alternate interior angles are also congruent. So angle 3 to angle 6, or angle 4 to angle 5. And guys, by the way, this little arc on the angle symbol means the measure of it. This symbol means the name. So right now we could use either symbol. But just to tell you, this means like angle 2. This means the size of angle 4. You could use either symbol right now. Now, same side interior. So like, well, I can't write this down yet. Same side interior would be like angle 3 and angle 5. Because same side and inside. But wait. This is obtuse and this is acute. Yeah, they sum to 180. Same side interiors sum to 180. So angle 3 plus angle 5 equals 180. Same story with angle 4 and angle 6. They would equal 180. Now wait, why? Well, we already said that angle 2 is the same as angle 6. And we know that if we look at angle 2 and angle 4, what do they together make? 180, because it makes a straight line. So if 2 is the same as 6, then 4 and 6 would also make 180. And same side exterior. Okay, well, 2 exterior, 2 and 8. What do you think the relationship between 2 and 8 is? Same thing, they sum to 180. Can anyone think of an angle relationship I didn't list here? There's one more that we need to talk about. Huh? We want a pair. There's no pair. So we did alternate interior, same side interior, same side exterior, alternate exterior. Write it down, please. Try to see if you can figure out what the relationship is. There is also alternate exterior. So, like angle 1 and angle 8, right? Alternate, opposite sides of the transversal. What do 1 and 8, what do you think they have? They're congruent to each other. Alternate exteriors are congruent. So take a moment, try to solve all 6 of these down here with the relationships we just wrote down up top. Yep, so go ahead and write on, you could write any of these angles, but you're specifically trying to solve for where they ask for x. Really, the relationship, we only saw 2 different relationships, right? Either they're the same, or they add up to 180. Right? So either they're the same or they add up to 180. And we can almost just like visually figure that out. We're going to do a little round the room today to help get you guys involved. All right, Audrey. What do you think this first one is here? Yeah, it is the same. They are same side but they're not interior, they're both, so these are actually corresponding, right? This first relationship would be corresponding. Please make sure you include degree symbols. Charlotte, what do you think about here? Yeah, this will be 129, because they are also congruent to each other. Logan, what do you think here? It is 85. Oh, all these top ones, I guess, were congruent to each other. I did not do this on purpose, but I now realize how this came out. Dewan! By the way, guys, we are not sitting in the... yeah, I got to move the seating chart. Are we aware that we're in the wrong places today? Or okay. Because it's okay. We'll figure it out Wednesday. Dewan, what about down here? Do you think... yeah, they're going to add up to 180, so we got to do the math and see that this is going to be 55. What about right here, Cooper? What? Oh, math is hard. Anybody? 88, right? Because they're going to be that sum of 180. And what about here? Our final x? Because my brain... sorry, I was saying the word 180, and that's why I wrote it down. What can we do for you, Mr. Cabilo? There you go, sir. You're welcome. Straight from Mr. Bezos himself. It's from Amazon. That's like, I'm going to see if Jeff can help me out. Like, Jeff Bezos is Amazon, kind of is the joke. Yeah, so like, when I text my wife, I ordered chisels from Jeff, and she's like, what? I'm like, Amazon. She's like, oh. I'm not funny. I don't think I am funny. I just like, I just say what I say, and it just happens, okay? Our final x here would be... I heard a lot. 2 is what I heard. 2. Hey, there's a vocab word we didn't talk about, but I think you already know it. These angle pairs that are adding up to 180, what do we call that? Man, we maybe don't know this. Everybody write this down. If 2 or more angles sum to 180, they are said to be... no one knows it? Supplementary. Here is how you remember it. Complementary angles is the other angle pair relationship that we talk about. Complementary angles add up to 90. And here again is my, I'm not funny, but this is going to help you. To compliment someone, excuse me, like I often do with Mr. Flynn because he's my boss. I'm like, hey man, I like that tie. To compliment someone is the right thing to do. Complementary angles make a right angle. People who take supplements want to get bigger. You take supplements, like vitamin supplements, to get big. So the bigger pair, the bigger relationship is supplementary. The smaller one is complementary. What's up? Just on the counter there's fine. Thank you very much. So, if that doesn't help you, I don't care. I'm just trying to help you. Like, if that doesn't help you, whatever. Move on with your life.
The way we learned it was complementary only has 1 key, which if you turn around is 9, and then just add 0.
Yeah.
Complementary has 2.
So, if you really want to know why complementary angles are called complementary angles, go look around the school. Look around your house. Look around anywhere. Your brain can tell when things are not 90 degrees or when things are supposed to be and don't quite line up right. Like, as soon as you walk in these classrooms, you're like, hey, the ceiling is not it's not flat. Your brain recognizes that. So, as I was trying to make my chessboard this weekend, because I am a giant nerd and it's COVID and I have to keep myself busy or I'm going to go crazy, all of these pieces that I cut were cut at complementary angles because when I put them together, they needed to make a 90-degree angle. So when you're making a 90-degree... Now, I don't have to cut them exactly the same size, right? I could make one bigger than the other, but they have to add up to 90. Now, these I did cut to be exactly the same size. I don't know if I have a good picture of the complement. No, I took these pictures because I am constantly texting with my dad about woodworking. So there you go. A complementary angle pair should line. Now, this isn't quite perfect, right? Because there's a tiny little thing. So I put some sawdust and some glue down in there. Complementary angle. I'm new. I'm trying to learn this stuff, right? So this is like a giant discovery day for me, trying to figure out how to do these things.
So you play chess?
I do play chess. Not very well, but... No. Flip your paper. Flip your paper. Flip your paper. It's so funny. What I didn't say was everyone start having random conversations. When we are solving problems like this, and this is one of the reasons I wanted to make sure that I got notes made for you guys, it helps us to write things on these images, which I know Khan Academy does not necessarily lend itself to, but guys, you can write on the screen. In Khan Academy, there's a little thing you can click to actually like pull up a pen and write on the screen. So, but right now, right on here, AOC is 104, AOB is 7x plus 30, BOC is 9x plus 42. Let's label all these. So AOB is 7x plus, okay, so this is 7x plus 30. This is 9x plus 42. This side of the paper is our other angle pair relationships. Because is this a perfect 90? No, this definitely would not be a picture frame. Is this a perfect 180? No, down at the bottom we have our perfect 180s. But so this, what can we do with these two expressions and the angle measure? Zoe? We can make an equation and solve it. Aha! So if we add up these angles, so over here in the beautiful space I left for us to do work, I know it's not graph paper and that breaks my heart, but over here, 7x plus 30 plus 9x plus 42, and if you wanted to, we could put these in parentheses to like, hey, these were our two different angles, but we really don't need to, equals what? 104. I like how the look you just gave me was like, duh, like 104. It's right there. It's right. It says it, man. Put your x's together. How many x's in total? 16 x's. Put your constants together. 30, 42, 72. There's a trap door coming up. What do I do on both sides? Subtract 72 and hope that I can do math. So x equals? Is that the answer? No. It's asking us to find BOC. The trapdoor on Khan is you're going to get excited when you get that 2. You're going to type it in. And in the split second it takes you to hit the enter key, your brain is going to say, that was no, and you can't take it back. Yeah, like you're going to be halfway down the button and your brain's going to be like, stop! And it's not, it's too late.
That's when you like slow.
It's too late. So guys, I'm telling you now, when you get the value for x, like take a breath, don't like rush to the keyboard, plug it into the angle that we're solving for. So for BOC, we're going to plug that into our expression or equation. We could really call it either here. What's 9 times 2? 18 plus 42, making BOC actually 60 degrees. Try the next one where we are finding QPR on your own. By the way, if you got an answer that just straight up doesn't make sense, like something bigger than 104, please always ask yourself, does my answer make sense? Hey guys, be very careful. I'm going to warn you of another trapdoor that some teachers like do this on purpose and they don't warn kids, and then they like, for some reason, get a kick out of it when kids make mistakes. I'm not like that. So here's what's up. Very soon, at least like on a test of mine, I might not give you little angle and little angle. I might give you the big thing and then one of the little angles. So just be really careful that you double check what they gave you and you don't just like immediately start adding stuff. So all I'm telling you to do is RPS, check that it's what you think it is. QPR, check that it's what you think it is. And now, okay, I can add them up because QPS, the big, the whole, okay. So this one is what we expected it to be. We got to add up the expressions. So when I add my x's together, 8x and 9x, 17x. 7 and 16 degrees. Wait, if 17x equals 17. Do not let that hand go to the keyboard. We then plug in, what are we trying to solve for? QPR. And it's 25 degrees. Questions on that? Yeah, and that wouldn't make sense, right? Yep. Always ask yourself, does it make sense? The only other, I don't know, I'm tripping on, well, my mask makes it harder. I'm telling you, that's why I talk kind of weird. The only other thing we really need to cover today is what does it mean if something is a straight angle? Well, first off, it's like an oxymoron, right? A straight angle. But Dewan, what's it mean? Yeah, it means that together it is 180 degrees.
It's a straight line.
I get the argument you're trying to make, but mathematically, straight angle has to be straight line with a vertex in the middle, because the straight angle literally arcs up like this. Like starts here, ends there. So LOM, okay, that's our acute angle. MON, Yaman, is our bigger angle. Guys, I told you I'm not funny. So if we add them up, okay, so 7x and 6x, 13x, 92 and 12, it's like 104, right? It's negative. So when we add the negative 92 and positive 12, but wait, can an angle be negative? Back yourself up. That question is moot. Moot means it doesn't matter. M-O-O-T, a moot point. If somebody says, oh, that's a moot point, it's like you brought up something that's true, but it doesn't matter. Whether or not an angle can be negative, well, technically not really. You can go the wrong direction, and that would be counted as negative, or if you open down instead of opening up. But this is not the angle measure. This is part of the expression that is going to equal what? 180. 13x equals. It's not 100. Trap door. You gotta add. Keep yourself out of that pit of doom. So that's where the trap door leads, if we haven't talked about that. Snakes, spikes, poison darts, the whole thing. Poison dart frogs, yes. And guys, especially when you get answers like 20, that's when you're going to like jump to type it in. Because like 20 could be an angle measure. I mean, any number could be an angle measure. But like, stop. That's not what our answer is. We need to find LOM. So 140 minus 92. So what is that? All right, do the last one on your own. We're finding BOC. Yeah, but I didn't put like the box. My answer doesn't need to go there. It's just telling me what to do. Then, you guys ready to have your mind blown? No.
Yes. Just give me about. Let's hear what those. Give me a minute. Yeah, I can't.
How can I have s'more if I haven't had any? Nobody?
Oh, no, I got that.
It's from the Sandlot, guys. How can I have s'more if I haven't had any? They offer him a s'more. He's never had a s'more before. And he says, how can I have s'more if I've never had it? I've not had any. Oh,
Someone who feels my pain, finally.
you guys didn't know that I work weekends as a magician. About to show you some math magic here.
You're a magician?
No, sorry, that was not true. Although I do like magic.
Because if you're a magician,
I know a few card tricks.
if you're a magician, you should just perform for them the entire time. Like, just have them entirely.
I mean, you guys have probably already seen my go-to card trick. Yeah. Yeah, yeah. No, they're not. They're all the same. Who would have a deck of all the same cards? You gotta be able to play poker. Alright, maybe if we get done with class, because I gotta teach you about triangles. What do we get for X here? It doesn't sound like we're very done. 3? Alright, you do not have to do this with me, but you are welcome to if you would like, but it's going to involve ripping a piece of paper. So, hey, shh. That does not just mean let's rip up a piece of paper, because that's wasteful, okay? But, check it out. I have made 2 triangles here, okay? I'm going to deal with the right triangle first. So, there is a principle in mathematics that relates to parallel lines and transversals, but really comes from triangles. So, if I have triangle ABC, And I have angles A, B, and C. I could really call them other things, but with how we're set up, we can just call them A, B, and C. I can assume that C is a right angle because it looks like it, but we don't actually know that for sure, right? Unless somebody notates it and tells us. I said it was a right triangle. Yes, you are correct. So, one really cool thing that I can actually do with this triangle is get mad at it and rip it up. It called me a name. It made fun of my handwriting, like a lot of you guys do. So, same triangle, right, but torn up, A, B, and C. So now, if I think about these angles coming together to try to hang out, they actually make a perfectly straight line. Same thing happens even if I have a non-right triangle with angles A, B, and C. If it called me a name or made fun of how I handwrite things, and I rip it up and put all of its angles together, you can call a cab and drive on a straight line. No, that definitely was not funny. But it just lines up, right? So if my paper wasn't a tiny bit folded here and it laid flatter, this is called the triangle angle, yes, it's very redundant, triangle angle sum theorem. So, the stuff we're going to dive into on Wednesday will come from our triangle angle sum theorem, but all that tells us, if you would like to write this down, you can, but you probably don't need to because you'll be able to remember it, is what's back on that blue poster is any triangle. I don't care how big, small, awkward, whatever, if it's a triangle, the three angles inside of it will add up to 180 degrees. So if you thought I wasn't funny, how about that poster? No matter how hot or cold it is outside, inside, it's always 180 degrees. Hot shot, because it's degrees. It's a homophone, because it's degrees and degrees. Yeah, I know, this wasn't really a joke. It just lined up to be. All right, so you have 10 minutes left in this period. And as you can tell from my notes, that's as far as I plan to make it today. So if you want to pull out your computer, work on some Khan Academy, I would love to take any questions that you have.